Happy day to all. Today we are going to see previous year net exam question, computer organization questions. Okay, yes, let's begin. The first question is A or A equal to A. This is called which law? There are so many Boolean laws, right? Identity law, De Morgan's law, idempotent law, complement law, distributive law, and many other laws are there. So in this, first one is identity law means what? A plus 0 equal to A, and then similarly A plus 1 equal to 1, and then A dot 1 equal to A dot 0 equal to 0. So this will come under identity law. This one is identity law. De Morgan's law is what? A dot B bar equal to A dash plus B dash. So this is an De Morgan's law. So idempotent law, A or A, that is equal to A, or we can say that A and A equal to A. So this is an idempotent law. So the first question answer is option C. And the D is complement law. So A, if you inverse and inverse, double inverse, that is we can say it as A. A double complement is equal to A. So this is a complement law. And the next question is an example of binary number which is equal to its 2's complement. So here they are asking, if you convert a particular binary number into its 2's complement, then the 2's complement is also the same binary number. So if you take option A, 1100, so find out 2's complement. 1's is 0011 and 2's is you have to add plus 1, right? So 0 and 0, 1 and 0. So this number is not same. So this number is not same, right? So option A is wrong. So take the option B number. So find out the 2's complement of this B option, then you will get 001 and 0111. This is 1's and this is 2's, right? So this number is not same as the given binary number. So this is also not an option. This is also not an answer. So when you see option C, 1000. So if you take the 2's complement of this given number, you can able to see. So this is 1's and this is 2's, right? So 000. So 1 plus 1 0 and the remaining 1 plus 1 0, remainder 1, and then 1 plus 1 2, that is 0 1. So that is equal to option C, which is same as the given number. So an example of binary number which is equal to its 2's complement is option C is the answer. And the next question is when the tri-state logic device is in the third state, then, so tri-state logic device is in the third state, then you can say it as there are three, one is 0 and another one is 1, and the tri-state logic is in the third state. It says that it presents a low impedance. It presents a low impedance. And the next one is an example of a connectivity which is not associative. An example of a connective which is not associative. So what is an associative law? A plus B plus C. This can be written as A plus B plus C. So this is called as an associative law. That is, you can do first these two things. You can manipulate this and then you can add. And similarly you can add B plus C and then add. The value does not change for these two equations. So this is called as an associative law. So if you take it as an AND gate, A dot B equal dot C, that is equal to A dot B. So if you do AND also, it will come under associative, and OR is also an associative. And if you take XOR means A exclusive B exclusive C, that is equal to A exclusive B exclusive C. So check it out, the truth table for this. You will come to know that XOR gate is also an associative, but they are asking which is not associative. Which is not associative? NAND gate is not an associative. So NAND is not associative. The question is not associative gate. Okay, NAND gate is not an associative. So if you want also, I will do truth table A, B and C. If you see, you have to take that 8 values, right? So first you have to do A plus B and then you have to do A exclusive C. So to check this whether it is an associative or not, take this down: A exclusive B exclusive XOR gate C, okay, and then A exclusive OR and B exclusive OR C. So first take down three variables are there, so A, B, C. So 4 0 4 1 and 2 0 2 1s and 0 1 0 1. So first find out A exclusive B. So what is A exclusive B? 0 0 means the output will 0. If it is 0 1 means what is XOR gate says? A B. A exclusive B is 0 0 0 0 1 1 1 0 1 and 1 1, the answer will be 0. So this is an XOR, right? So this is an XOR form gate output. So you can see A exclusive B first, 0 and 0, the output will be 0, and 0 and 1, that is output will be 1. 0 and 1, output will be 1. 1 0, output will be 1, and again 1 1 1 is, the output will be 0, and 1 1, the output will be 0. So now you find out A exclusive B, we have find out here. A exclusive B and exclusive C. This equation I am finding what is the result of this. So A exclusive B exclusive C, this you consider as X. So I am finding out. So 0 0, the output will be 0, 1 0 1, and 1 0 again 1 1 1, that is again 0, 0 1 again it is 1, and 1 1, this is 0, and this is 0, and this is 1. Okay, so in the same way, if you find out truth table result for A exclusive B exclusive C, okay, now I am find outing B exclusive C. So take B and C. 0 0, that is 0, right, and 0 1, that is 1, and 1 0, that is 1, and 1 1, that is 0, and this 0 0 again 0, and 0 1 again it is 1, and 1 0 it is 1, and this is 0. So B exclusive C I found, and then A and B exclusive C. So 0 0, this part, A plus B exclusive C. So this you consider as Y. So what is the output of Y? 0 0, the answer will be 0, and then 0 1, that is 1, and then here 0 and 1, that is 0. So this is 0 and this is 0, the answer will be 0. Take the correct value, 1 2 3 4 and then 5. Okay, 1 0, that is again 1, then 1 1 is again it is 0, and this 1 and 1 again 0, and 0 and 1, this is again 1. So now you can observe that this value is equivalent to this value, right? So we can say it as LHS equal to RHS. So I said that exclusive OR is an associative. A exclusive B exclusive C, that is equivalent to, we can write as A exclusive B exclusive C. Okay, so work out slowly this truth tables, you can get the answer. The next question is essential hazard may occur in. So essential hazard, so in a circuit sometimes some hazards will happen. So when it is happening means normally when it is a synchronous, when it is going by line, there is no hazards will happen, or in a combinational circuit no hazards. So in a asynchronous only normally hazards will have. Hazards means some dangers or something will happen, okay, unwanted things. So in an asynchronous means multiple people who are coming in the same time, so what happens? Collisions will happen, right, like that. So asynchronous sequential circuit working in a fundamental mode, when asynchronous sequential logic circuit working in the fundamental mode, at that time only essential hazards may occur. So asynchronous sequential logic circuit working in a pulse mode, whenever the clock pulse is there, then there will not be any essential hazards. Okay, so option C is the correct answer. The next one is the characteristic equation of T flip-flop. So always the T flip-flop is toggle flip-flop. Whatever the value you are given, that is 0 means 1 and 1 means 0. Okay. So option A, this is flip-flop. I will take separate class also. So qn plus 1 equal to t q bar n plus t bar qn. This is nothing but this you can also written as t exclusive qn. The output is exclusive or with the toggle input. So the same expression also written in this way also. This is also correct and this is also correct. Okay. So this is called as a toggle flip-flop. The next question is, suppose x and y are two integer variables having, okay, there are two integer variables x and y respectively. The result of applying bitwise operator and to x and y will be. Consider here 0x is indicating the hexadecimal value. Okay, 0x indicates hexadecimal value. So 5ab6, 5ab6 is one number, that is x, and another number is y, that is 61cd. So now they are telling that the result of applying bitwise operator and to x and y. So now I am applying bitwise and means I am just AND gate. I am doing with this bit and this bit. So now first you have to convert this into an what? Have to convert this into an hexadecimal value. So 0101 and for A is 10. So I am written as 8010 and then B is 11, right? 1011 and 6 can be written as 110. So I am just writing binary equivalent for each and every letter. So 6 can be written as 0110 and 1 can be written as 0001 and C is nothing but 12, right? So 10, 11, 12. So 8, 4. So 8 1100 and then 12, 13, 1101 is the answer D. So now I am doing AND 0.1, 0, 1.0, 0, 1.1, 1 and then this is 0 and this is 0, 0, 0, 1 excuse me, sorry. So 0.1 that is 0 and 1.0 and then again 0, 0. This is 1.0 and 1, 0. So now you have to convert this into an equivalent hexadecimal value. So this is an 4 and this is an 0 and this is an 8 and this is an 4. So this is an hexadecimal number. So I am representing as 0x. So the answer is 0x4084 is the answer. The next one is the processing speed of pipeline segments or usually. So in a pipeline we cannot say all the segments speed will be equal. So in a pipeline, because there are pipeline means what? Different segments are connected. So the processing speed of that each and every process will be different. It may be the processing speed of pipeline segments are usually unequal. Segments they are asking, okay. So speed of a pipeline segments are usually unequal. And the next question is, this is a binary value. So they are asking 53 is what kind of base? Now you have to convert from one the base of this number. So obviously B is not a 4th base, because if it is a base 4 means the value will be up to 0, 1, 2, 3. So 5 won't come here, right? So 4 is not 4, base 4 won't be come here, okay. And next we will check it out for octal. So to find out octal value, first I have to convert this number into a decimal number. So how can I convert? So using 8421 I can convert easily, right? 1, 2, so add it 32 plus 8 plus 2 plus 1, 32, 40, that is equal to 43. If you convert this 43 divided by 8, 5 8s are 40, remainder 3. So 53 is just an octal value of this given value. So option B is the correct answer. Okay, once we can find out, we no need to check out the other options. Okay. So the next one is the logic expression reduces to. So how can I reduce the, what is the common thing is there? X bar y, and then if I take z bar plus z. So what is this? This 2 common x y. So x y if you take z bar plus z. So z plus z bar equal to 1. So I am just leaving that, and then I am written x bar y plus xy. So if you take y is the common thing, right? So if you take y is common, x bar plus x equal to 1, and the answer is y, because x bar plus x equal to 1, right? So that is available in the option C. The next question is, which of the following logic has maximum fan out? So maximum fan out is CMOS. This we have to read out the logic family table properties. The next question is, which of the following binary number is same as its 2's complement? This I explained in a previous question itself. The same question repeated for 2 more exams. So the next question is, identify the logic function performed by the circuit shown. So here this line is x, the input x is coming, here it is y is coming. So when it come here x, so this is nothing but NOR gate. So NOR gate will give x plus y the whole bar. So if it is taken after this, so it will come x plus this value plus this value the whole bar. Okay, so x plus y the whole bar, okay. Similarly here y plus x plus y the whole bar. So when the function output f equal to, so these two things, x plus y the whole bar, this, okay, plus y plus x plus y the whole bar, this, the whole bar. Okay, so when you split this complement, the addition will become AND. Okay, so then it will become x plus y the whole bar, this complement and this, and make it as and y plus x plus y the whole bar, and this and this. So now as per the complement law, what says, if it is a double complement, you can remove it. Okay, this is a double complement, right? X double complement equal to x. So remove this complement and you can written as x plus x dash dot y dash. Then similarly here y plus x dash dot y dash. So now if you multiply, you will get x dot y, so xy plus x into x bar equal to 0. X dot x bar equal to always 0, right? So if you want to multiply, you can multiply, otherwise you can leave it as. So x dot x bar, it will become 0. So I am leave it as 0. And if you multiply this and this, y dot y bar equal to 0, then I am placing as 0. And the next one is this and this. So a dot x dot x equal to x. So these are all the laws, right? So you can written as once x bar dot y bar. So what is this xy plus xy plus x bar y bar? That is equal to exclusive NOR. This is not an OR and exclusive NOR. Very careful in the question. So this is an x dot exclusive NOR. This is an exclusive NOR question. Okay. So option C is the correct answer, exclusive NOR. So if you use, you will get, just rather than this circuit, if you draw this exclusive NOR circuit, you will get the same circuit, same output. Okay. Exclusive OR is A bar B bar plus B A bar, and exclusive NOR is XY plus X bar Y bar. Just check it out the table. The next question is, the proposition negation P implies Q is true, then the truth value of proposition. So I am able to know that is negation P R implies Q. So there is no such an equation in this. So we cannot determine, by using this equation, we cannot determine what will be the output of this equation. So the option is cannot determined. And the next question is, which of the following is divisible by 4? So if you want to identify which is divisible by 4, last 4 digits, okay, last 4 digits you have to take. Whether if it is divisible by 4 means then the whole number is divisible by 4. Here the tips is, if the last 4 digits, okay, in a binary, okay, so this is an 12, right? Only I am taking last 4 digits of a given. This is 1 and this is 3 value and this is 10. So 10 is not divisible, 3 is not divisible, 1, and 12 is divisible by 4. So option A is the correct answer. And the next question is, an off adder is also known as. So what is the off adder? It is used to add 2 binary bits. You will get sum and carry, right? Sorry. So off adder is a circuit which is used to add the 2 binary bits. In this 2 binary bits you will get a sum and the carry, right? So to identify the sum, I am just using A exclusive or B. So here you are getting the sum, and in this if you are doing AND means A dot B means you are getting the carry value, and this is nothing but exclusive OR. So an off adder is also known as XOR circuit. An off adder is also known as SOR circuit. XOR. Yeah, exclusive OR circuit, because I am using exclusive OR, right? Here I am using exclusive OR gate. So this off adder circuit is also called as exclusive OR circuit. The next question is, when an inverter is placed between both inputs of S and OR flip-flop, the resulting flip-flop is. So this is an S and this is an OR. So you are getting Q and Q0. So if you are placing inverter here, then this flip-flop will be considered as D flip-flop. This flip-flop will be act as D flip-flop. Okay, so when an inverter is placed between both inputs of an SR flip-flop, so this is S and this is O. If you are placing an inverter in this between, then the resulting flip-flop is called as an D flip-flop. Okay. The next question is, consider the following circuit to make it a tautology. So if I want this F to be always true, if I want this F to be always true, what gate I have to place here? Okay, so that is the question. To make it tautology, the question mark should be whether I have to place NAND gate, or whether I have to place AND gate or OR gate, or whether I have to place XOR gate. So in this kind of question, what I have to do is, so this is X and this is Y, right? So this is an OR gate. So what happened? X plus Y. Okay, the output will be 0, 0, 0, and 0, 1 will be 1, and 1, 0 will be 1, 1, 1. So this is an XOR gate. So this is the only thing 0 coming here. So to remove this, if I place OR gate here, the 0 will be come again, because this is also an OR gate. So OR won't come. Okay, if I use AND also, 0.0 will become 0 only. So I can't use AND. So if you use it NAND gate, so what happen you see? So if I use NAND gate, it will become 1, 0. So first of all, NAND gate output is what? What is NAND output? So x dot y, 0.0, 0, 0, inverter 1, 1, and then again this is also 1 and this is 0. So what happened you see, if you watch the last OR gate, if you do this 0 plus 1, 1, 1, then 1, and this is also 1. Okay, so if you place the NAND gate, the result of this circuit F will be always true. Okay, so the answer is option A. The next one is, the preposition P implies Q and negation Q or P. So negation Q or P can be written as Q implies P. So Q implies P. This is only they written as negation Q or P, right? So you can modify this negation Q or P as Q implies P. So where is the equation? So this is A dot B. So you can write Q implies P and P implies Q because it is an associative. So option C is the correct answer. And the next question is the number of ones present in the binary representation of 3 into 512. So they are asking they are giving in this kind of question. What is the trick is, this is not 10. Number of ones present in the binary representation. So no need to multiply all the values and no need to find out the binary number. For this you have to take only these odd numbers. So 512 is an even number, right? These are all 2 to the power. So leave this 2 to the power. If there is any 2 to the power of, that is 2, 4, 8, 16, 32, 64 and 128, 256. If there is any 2 to the power, just leave the 2 to the power and take the remaining amount. For 3 it is 1 1 and for 7 it is 1 1 1, right? And you take only this 7 5 3 and this 3. Okay, so 5 is 101 and for 3 is 0 1 1. So in this, find out how many number of ones. 1 2 3 4 5 6 7 8 9. So there are 9 ones are there. That's it. So option B is the correct answer. The next question is, which one of the following expression removes a static hazard from a two-level AND OR gate implementation of xy plus z x bar? Xy plus z x bar, you can written as here x and x bar, right? So to remove this hazard, there will be the yz will be in the equation. So option C is the correct answer. Which one of the following logic has the maximum fan out? Maximum fan out is CMOS. And the next one is in a weighted code with the weight. Normally they are using 8421 method, right? 8421 method. If they are using the weight code as 642 minus 3, then the decimal digit 5 is represented. If I want 5 means wherever I have to present 1. So if I want 5, so 6 plus 2, 8. 8 minus 3, it will become 5. So 1 0 1 1. If I present this, I can get decimal 5 value. Okay. The next question is, up to how many variables can the Karnaugh map can be used? So in to solve, we can use many variables as much as possible. We can use it. Simplify using Karnaugh map. So 3, 4, 5, I am choosing the highest variable. Okay. So up to 6 variables also we can solve using the Karnaugh map. Okay. The next question is, the proposition negation Q R P is equivalent to. This can be written as Q implies P. So here negation and here it is R. So the answer is C. Q implies P. Okay. The next question is, in 8085, which of the following performs load register pair immediate? Load register pair immediate. Okay. That is LXI register pair. RP indicates register pair and data. If I am assigning the data value immediately to the register, then it is called as load the register pair immediate operation. Okay. Here it is called as a load the register. LDAX. Here LHLD address is, it is loading the address to the HL register pair. Okay, it is increment the register pair. INX means it will increment the register pair. That is, it is increment HL register or BC register pair. So like that, if you want to register increase the register pair, I am using INX. If I want to load the register pair with the data, I am using LXI register pair and data. So for example, LXI BC comma 80. Okay, some values. Okay. So 80 will be assigned to the BC register immediately. And the next question is, the hexadecimal equivalent of this So the hexadecimal equivalent, if I want to identify hexadecimal equivalent, first I have to convert this into an decimal value. So if I want a decimal value, what is the decimal value for this number? 8, 16, so 16 plus 4, 20, 23 here, and 1110, this is 8421, right? So 8 plus 2, 10, 10 plus 4, 14. So this is value 14. So 4 is 12, 2 remainder 1, 8, 9, and 23 to 322 is the decimal value. Okay, this is a decimal value. Now I want an hexa value. Okay, what is they're asking is what is the hexa equivalent of this one? So 322 divided by 16. If you want to hexa means I have to divide it by 16, right? 2 16s are 32, and then 0, 20, and then remainder is 2, and then again 16, 1 16s are 16, remainder 4. So 142 is so 142 is its equivalent hexa value. Yes, the next question is an example of self-complementing code. An example of self-complementing code is XS3 code. It's not gray code or 8421 code and all. We are finding out in the decimal value for that we are using. Self-complementing code is XS3 code. The next one is a sum of product expression can be implemented with logic gates. A sum of product expression can be implemented with a logic gate. Okay, what is sum of product? What is sum of product? Sum I am doing with the products. Okay, so A bar, B bar, C, and A, B bar, C bar. So if it is written like this, this is called as an SOP format, or we can say it as sum of product. So for that what we are using is, first we can take it as this product. So for tips product as first, for to find out the product I have to use AND gate, and for a sum I have to take OR gate. Okay, for SOP what I have to do, first I have to AND all these things, and then I have to do OR gate, right? So AND and OR gate will be implemented for SOP. For POS I have to written as OR AND. For SOP, sum of product expression can be implemented with the logic gates and then OR. Okay, we are not going to use NAND and all, so you can remove this NAND not we are going to use. Okay, a sum of product, first product you have to take and then you have to OR. The next question is the characteristic equation of the D flip-flop. So D flip-flop is nothing but a data flip-flop. So whatever the value is coming inside the flip-flop, that is the output. Qn is the output, right? So whatever the value is given here, that will be the output. Okay, so this is called as a D flip-flop. So whatever the value present in the D, that will become it as a Qn. Okay, so Q of n plus 1, the next state will be nothing but the given data. 0 means 0. It is also just we can say it as buffer. So what happened buffer, the value will be stored and the same value will be given to the next state. The same thing, the data is given to the next state. Okay, D flip-flop is nothing but a data flip-flop, just it is stored temporarily for a while. So Q of n plus 1 equal to D. The next one is which of the following logic is the fastest? So normally fastest is emitter couple logic. ECL is the fastest logic family. Emitter couple logic. So the first one is TTL and transistor logic, and then other things. And the logic which is the fastest is emitter couple logic. Okay. And next one, the 2's complement of minus 100. The question, remember, minus 100. So you have to find out what is 100 binary value. So 52s are 100, remainder 0, so 2, 25, 2 so 50, and then remainder 0, 12, 2 so 24, remainder 1, 12, 6, 2 so 12, 0, 2, 3, 2 so 6, 0, 2, 1, 1, 1, okay. So now you take this binary number 1, 1, 0, 0, 1, 0, 0, okay. This is the equivalent binary value. So now you want to find out the 2's complement. 2's complement, 1's complement is this. Okay, this is 1's complement. So 2's complement you have to just add 1, 0, 0, then 1, 1, 1, 0, 0. Okay, so this is the equivalent 2's complement, and then 1, 2, 3, 4, 5, 6, 7, the 8th bit. Okay, 8th bit is called as a sign bit. This is called as a sign bit. So this is a minus 100, so it has to represent 1. So 1, 0, 0, 111, 00, that is available in option C. So very careful in this. See, the same value is given in option A also, but it is 0 because that is a positive 100. This is a negative 100. Okay, the next one, which of the following expression remove hazard from xy plus zx bar? So same thing, x bar. So just take this y and z. Okay, so option C is the correct answer. The next one is how many ones are present in the binary representation. So whatever the expression they have given, you can remove the 2 to the power and then see. So 15 and 5 and 3. Take only this odd numbers. Not 2 to the power. Okay, 256 is it's a 2 to the power, and 16 also 2. So 15, 5, 3. So find out number of ones in this. So 15 can be written as 1, 1, 1, 1, and 5 is 1, 0, 1, 3 is 1, 1. So how many ones? 1, 2, 3, 4, 5, 6, 7, 8. So option A is the correct answer. How many number of ones present in the binary representation is A. Option A, 8. So in this question they are asking take A exclusive B, that the output will be C. Then you can say what you say about this A exclusive C equal to B or this and all. So for this, first I have to see A and take only 2 variables. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Okay, this is A and this is B. So what will be the C? This is A exclusive B. Exclusive B means 0, 0 output will be 0, 0, 1 output 1, and 1, 0 output 1, 1, 1 is 0, right? So this is C. So what happen if you do A exclusive C? So if I take A exclusive C, if it is coming B, I have to check. Then do A exclusive C, 0 and 0, take this and this. So 0, 0, 0, 0, 1, 1, and 1, 1 is 0. Take A and C alone to check out this equation is correct or not. And 1, 0, that is equal to 1. This is nothing but A exclusive C equal to, this is nothing but, this is an B. See, the output is similar to B, right? This is 0, 1, 0, 1, and this is equal to 0, 1 and 0, 1. That is A exclusive C equal to B is the correct one. And if you check out similarly like B exclusive C, if you do B exclusive C, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1. So this is nothing but B exclusive C is nothing but, this is A, 0, 0, 1, 1, and here also 0, 0, 1, 1. Okay, so option B is also correct. If I do A exclusive, B exclusive C, what happens? 0 exclusive, 0, 0. So the answer will be B exclusive C, A exclusive, B exclusive C, that is equal to 0 exclusive 0, 0. 0 exclusive 0, that is also 0. So 1 won't come, right? So 1 won't come. So if you take 0 exclusive 1, 1. Sorry. 0 exclusive 1, that is 1. 1 exclusive 1, it will be 0, right? So this is also 0. And then 1 exclusive 0, 0. Sorry, 1 exclusive 1. 1 exclusive again 1, that is equal to 0. Here 1 exclusive 1, 0. 0 exclusive 0, 0. So the output is always coming 0. A exclusive, B exclusive, C. So option A and B and D, both these 3 options are correct. Okay. So in below they can give A, B, D is correct and A, B only correct, right? So I have to check out all these things, you can do it. And the next one, what is the maximum counting speed of 4-bit binary counter which is composed of flip-flop with a propagation delay of 25 nanoseconds? So in this question, 25 nanoseconds is a propagation delay for one flip-flop. So 4-bit binary counter. So 4 into 25, 100. So 1 divided by 100. This is represented in 10 power minus 9. So if you do 10 power 9, what happens? If it goes 1 divided by 100 into 10 power 9, this is but 10 power 7. So 10 power 7 can be written as 10 kilohertz. 10 power 6 is megahertz, right? Megahertz, 10 power 6. So 10 megahertz is the answer. So option B is the correct answer. The next one is a well-formed formula that is equivalent to x tends to y. X tends to y. In a contrapositive law, we can say it as negation y tends to negation x. So option C is the correct answer. The next question is simplified form of Boolean expression. So how can we simplify this? So to remove this hazard, we can just leave this yz, xy plus x bar z. So xy plus x bar z. Option A is the correct answer. So they can give reversely xy plus x bar z. How can we remove the, and then you can add yz. In a previous question we can see, right? Same thing. So the next question. In order to build a mod 18 counter, the minimum number of flip-flops needed is equal to mod 18 counter. So for this 18, if I want 18 means, so see normally if I want 16 means how many times I have to use 2 power 4. Okay, I have to use 4 flip-flops to get the 16 values will be getting. Okay, so if I want mod 18 counter, so I have to use one more flip-flop. Okay, 2 power 5, that is equal to 32 values I can get. So I have to use 5 flip-flops. Okay, whatever they give, you have to find out 2 power n. Find out the greatest 2 power n. Then that n is the number of flip-flop. So here 5 flip-flop is needed. The next question is the dual of the switching function. The duality means changing and as or and or as and. So x plus yz. The duality is changing and as or and or as and. So I am changing here. Here it is a and, no. So I am changing, here it is an or. So I am changing as and then y here dot means I am changing as z. So this is called the duality function of this duality. So x dot y plus z, option B is the correct answer. The next question, among the logic family DTL, TTL, ECL and CMOS, the family with the least power dissipation is called as CMOS. So the least one is CMOS, the highest one is ECL. Okay, emitter couple logic. The next question is the performance of a file system depends upon the cache hit rate. If it takes 1 millisecond to satisfy a request from the cache but 10 milliseconds to request if the disk read is needed, then the mean time required for the hit ratio. So normally how you are giving hit ratio plus hit ratio into cache main memory, right? So main memory into 1 minus h into main. So main memory here says that 10 milliseconds to satisfy the disk read. So 10. So h plus 10 into 1 minus h is the answer. Okay. So here it is 1 milliseconds for request from cache. Okay. So 1h. So 1, this is an TLB and this is for main memory. So h plus 10 into 1 minus h. The next one is an example of tautology. Tautology means always true. So whenever the function value must be always true, then it is called as an tautology. So when it is true, x bar x or negation x. When you do this, always the function value will be, output will be true. So x or negation x is the answer. So the same question, among the logic families, which is the fastest? Emitter couple logic. Which is the slowest? That is CMOS. Okay, complementary metal oxide semiconductor. The next question is the octal equivalent of the hexadecimal number. So FF is an hexadecimal value. To convert from an hexadecimal to octal number, the shortcut is first you have to return it as an 8421 value. So what is for F? So 1111 is the hexadecimal value for this. So to find out octal value, group into 33 bits. Group into 33 bits. And previously you just add 0. So this is 7 and this is 7 and this is 1, 2. It is 3. Right? So 377 is the equivalent octal value. The next question is the characteristic equation of a T flip-flop. I already told no, toggle flip-flop. Toggle flip-flop means what? T bar Qn. We already see no T bar, and in that question they have given like this. T bar Qn plus T Qn bar. So this you can written as T exclusive Qn. So that is given in this output C. The next question is the idempotent law in Boolean algebra says that we have already seen that x plus x equal to x and x and x, that is also x. This is called as an idempotent law, that is available in the option B. And x double complement is it. This is an complement law and this is an absorption law, another C and D. And the next one again, the dual of the switching function, change and as or and as x dot y plus z. So option C is the answer. So the characteristic equation of D flip-flop is always the output is D. It's not a D bar or 0 or 1. So whatever the data present in the flip-flop, that will be given as an output. So that is the purpose of D flip-flop. Always Q and the output will be D. The next question, extremely low power dissipation and low cost per gate can be achieved in. So low cost. So always low cost per gate can be achieved using CMOS ICs, that is complementary metal oxide semiconductor integrated circuits. These are all used in MUP, microcontroller and many other things. Okay. So CMOS complementary metal oxide semiconductor integrated circuits. The next question is an example of a universal building block. Universal building block is, so using that gate I can build all other gates. That is called as an universal building block, right? So what are the gates? That is NAND and NOR gate is called as, these two gates are called as universal gate. So NAND is not here, so NOR gate is an answer. Option D, NOR gate is an universal gate. The next question is, suppose it takes 100 nanoseconds to access page table, 100 nanoseconds to access the page table and 20 nanoseconds to access the associative memory. Associative memory. So this is a main memory, this is an TLB. Okay. So first we have to identify correctly which is main memory and which is a TLB. If it is means, then we can easily identify. If the average access time is 28 nanosecond, the corresponding hit ratio. So we have to find out hit ratio. So what I have to do? So 28 equal to average access time. So average access time equal to, what is the formula here? TLB into hit ratio plus 1 minus h into main memory, right? So TLB is here 20. So 20h plus 1 minus h into 100. Okay. So this is an average access time. So I have to find out h here. 20h equal to 100. So multiply 1 into 100. 100 minus 100h. So 100h means this is 80h. So if you take 80h this side, this will become positive. 80h equal to this, take this 28, this side 100 minus 28. So that is equal to 72. So h equal to 72 divided by 8. That is nothing but 0.9. That is 90%. So the hit ratio is 90%. The next one, in which addressing mode the effective address of the operand is generated by adding a constant value to the content of the register. So that is called as index mode. Okay, index mode is nothing but you are adding every time some constant value. Okay, if the value is data is 5, I am adding some 100. Okay, if the value is adding and then 600, so 105th value I am storing the 5. Okay, 106 I am storing 6. So some constant value is added with the operand to the content of the register. So such a mode is called as index mode. Such a mode is called as an index mode. Immediate mode means we are assigning the data. So that is called as an immediate mode. So this one is index mode. Okay. So the next one is the Boolean expression is equivalent to. So how can you solve this? So take which is common here, yz x bar z. So z. So z is common in all, right? So we're taking z x bar y bar plus y plus x. So then x, here x, and here it is x bar. So for x bar I can written as x plus y bar plus y. So y plus y bar you can say it as 1. So x plus 1. 1 plus x equal to 1 only. So as per the identity law. So z is the answer. So option C. And the next one, the characteristic equation of JK flip-flop. JK flip-flop is J dot Qn bar plus K bar dot Qn, the output. Okay, here J and K. Here it is, but it is nothing but exclusive. So Q of n equal to, the next state will be J dot Q bar n plus K bar dot Qn, exclusive or actually. And the next one is not exclusive or no, not, you cannot say that exclusive or just J Q bar n, and here it's Q because it is K, right? K bar. The next question is, with the 4 programs in memory and with 80% average IO weight and CPU utilization is. So the formula for CPU utilization is 1 minus P to the power of n, that is equal to 1 minus P is 80%. 80% you can written as 0.80 to the power of 4 programs. N is number of programs. N is number of programs. That is 4. So if you multiply 1 minus, so 0.80 multiply by 4 times, 0.80 into 0.80. So that is 0.64. So 0.64 into 0.64 you will get 0.4096 something. So if you subtract 1 minus 0.4096, you will get 0.60 something. So that is 60%. With your 4 programs in memory and with 80% average IO weight, the CPU utilization is 60%. The next question is the octal equivalent of hexadecimal. The octal equivalent of hexadecimal. So already told that if convert this hexadecimal into octal, first you have to convert this into a binary. So A means 10, 10, 10. And then B means 11. So 10, 11. Now you have to group into 3 bits. Group into 3 bits to convert into an octal. Okay. So but this side. So for the whole part you have to do group into 3 bits by right to left. For the decimal part we have to left to right. Okay. So now this is 0, 1, 0 is 2 and this is 1 and this is 5 and this is 4. So 12.54. So this is a mistaken one. So 12.54 is the equivalent octal value for this given hexadecimal. The next question is a reduced state table has 18 rows. The minimum number of flip-flops needed to implement the sequential machine. So I have to find out 2 to the power of n. So that is equal to 2 to the power of 5. So 2 to the power, you can get only 16 rows. If I want 18 rows, I have to use one more flip-flop. That is 2 power 5, you will get 32. So I am using the next maximum level. So C, option C, 2 power n. So n is the number of flip-flops required. So 5 is the answer. The next question is, suppose it takes 100 nanoseconds to access a page table and 20 nanoseconds to access associative memory with a 90% hit ratio, the average access time. So average access time formula is TLB into hit ratio plus 1 minus h into main memory, right? So what is the TLB? That is nothing but associative memory is TLB. Okay, so 20 into hit ratio is 0.90. So 1 minus 0.90 into 100 nanoseconds. Main memory is, this is page table is called as a main memory. So 20 into 19, 18, right? 180. So decimal, 1 decimal plus 0.10 into 100. So nothing but 10. Okay, so 18 plus 10, that is equal to 28 nanoseconds is the answer. Okay, option B. So the average access time equals 28 nanoseconds. The next question is the prepositional formula given by the tree. So the prepositional, this is a tree, we have to get the value. Okay, x1 bar or x2. So x1 bar or x2, then this is a group, and then and x1 bar or x2. So left, root, right. So where is this x1 or x2? So this is available in option C. The next question, in which addressing mode the operand is given explicitly in the instruction itself. So the operand is given explicitly means they are giving directly in the instruction itself. For example, L, XI, B, C, or move immediately, B, 20. So 20, the operand value is given directly in the instruction itself. Okay, so that is called as an immediate mode. So in which addressing mode the operand is given explicitly in the instruction itself, that is called immediate mode. Okay, the next question is the simplified form of a Boolean expression. The simplified form, so here x plus y plus xy into x plus z. So what is the common here? X. So if you take x into 1 plus y, right? So 1 plus y equal to y. So x plus y and x plus z. So how can I written as x dot x plus xz plus yx plus yz? So x dot x I can written as x, right? Plus xz plus yx plus yz. So take which is commonly x, 1 plus z plus y. So 1 plus any number equal to 1, right? So this will becomes 1. So the answer will be x plus yz is the answer. So which is available in the option C. The next question is identify the logical function performed by the circuit shown. So take which is already explained, this is x and this is y, this is x plus y the whole bar, and this is x plus y the whole bar, which is already executed, which is nothing but exclusive NOR, the same question repeated. The next question is the highest noise margin is offered by TTL. Highest noise margin is offered by TTL. The next question is the answer of the operation in hexa equivalence. So first we have to find out the binary value 1, 2, 4, 8, 16. So 16, right? 8, 16 plus 23. 23 into 8, 4, 2, 1. So what is the value for this? 10, 14. So when you multiply, so 2, this is also already explained, no? 1, 4, 2. 3, 2, 2 is a decimal value. When you divide it by 2, 6, 12 and 0. Okay, 1, 16, 1, 4. So 1, 4, 2 is the equivalent hexa value that is available in the option C. The next one is how many ones are present. So to find out how many ones, we have to take this odd values. This is here 3, this is 7, and this is other. So other is what? So others are 2 to the power. Just leave that. So 3 means 1, 1. 7 means 1, 1, 1. And 5 means 1, 0, 1. From 3 again, this 3 means 1, 1. So how many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of ones present is option B, 9. So if an error detection and correction code, a message "you are good students" is stored as M. Okay, so you are, this is an M dash, you are or you, and they are given as a combination of this. What is the space required to store M dash in general? So when you count this number of letters here, it will be similar, like it is not like a 2n or it's not 3n or 4n exactly, but it is commonly we can say it as less than 4n. Less than 4n. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 characters, and here this in M dash, which is greater than 20, and which is not equivalent to exactly 2n or 3n or 4n. If you say less than 4n, this will come under all this category, 2n also, 3n also, 4. So they are telling that option D is the correct answer. The next one is statement P. Program is a step-by-step execution of the instruction. Is correct. And programming is a subset of an instruction set. Program is a sequence of subset of an instruction set. Okay. When you say any subset of an instruction set, then it is called as a module. So we can say that program is a sequence of subset of an instruction set. When you add some group of modules, you can say that it's a program, group of tasks in one program. Okay. So in a main, one program, on subtask 1, okay, and subtask 2, we can say the exact definition for programming is, it is a sequence of subset of an instruction set. We cannot say subset of instruction set. We can say that program is a sequence of subset of an instruction set, and it is also not a partial order. We cannot partially, it is not a program. We have to complete full of sequence of set is called as a program. So option B is the exact answer. The next question is the logic expression for the output of the circuit shown in the below. So this is A and this is B. Here it is A plus B the whole bar, and if it come here, A plus B plus C the, this bar will come, and again this bar will come in the second NOR gate, and here it is C plus D the whole bar. Okay, so when you add this and this, so A plus B plus C the whole bar here, and this plus C plus D the whole bar, the whole bar. Okay, very careful when you are writing the complement and things and all. So don't do first evaluation. First you written as it is and then split it. So now this AND will be OR will be became AND, because complement will be cancelled, right? So keep it as it is, C, then dot, this AND will become dot, C plus D, this complement and this complement. So this double complement will cancel, this double complement will cancel. This you can written as a bar dot b bar plus c, and here you can call it as c plus d. So if you multiply this, what happened? A bar b bar c bar, a bar b bar c plus a bar b bar d plus c dot c, c plus cd, right? So this is the correct answer. When you take c, what happens? C, when you take 1 plus d, so 1 plus d will become 1, okay, c. So if you, okay, this will become 1. So if you take c again, 1 plus a bar b bar will come plus a bar b bar d will come. So this will become 1. So c plus a bar b bar d. So the answer is a bar b bar d plus c is the correct answer. Here none of the option is correct actually. They have given wrongly. A bar b bar. So this all the options are wrong. So options are wrong. So here the correct answer is a bar b bar d plus c.